Welcome back. It's tutorial number 7, and today we're gonna bow a plate because that's also something we rarely can manage to do in the real life. First of all, to have a plate. Second of all, have it in a material of our liking, changing sizes whenever we like, but also to bow it. We can bow it on the edge, but nowhere else. But in Modalys, everything is possible. So let's get right to it. If you remember the bow example from tutorial number 2, it's actually only about really keeping a very good track of what is horizontal and what we define as vertical. So we need the B2 mass object this time. We're gonna push it down, but we are also going to, so it's going up and down, but it's also going left and right. We're gonna use a speed controller again, although you also can use position for that. Actually, the example I think they have in Max uses position for both. Let's start directly. Here's a new buffer, and as always, we're gonna do it from A to Z. So, and as always, there will be bookmarks, so you can also jump over anything you like. So, in package, and this, and make the bow. So we are going to use today a bidirectional B2 mass because we need to be able to move in both directions. So we're gonna set Q my bow, make object B2 mass. I'm gonna leave it like that for now. No special non-default settings for now. And next we're gonna make the plate. So set Q my plate, make object and rect plate. And here I am going to go, because we want to be able to change these properties. Here. There we go. You can also do this with other plates. Try everything out that you like. Modes. I'm going to 100. Length. So length 0, 0.5. Length 1, 0.5. The thickness is going to be 0.01, so 1 centimeter. The density for now 7800. Poisson 0.3. Young 2E11. The frequency loss we are already gonna put down. I like it more, so 0.8 I would say, and the constant loss 0.8 as well. Okay. Oh, set W. Okay, set Q. Okay. Now we are gonna set the pitch through to my plate, through size to something nice and deep, 60 Hertz. Okay, that's this. Now we are gonna make the axes. And we have to be very, very sure to keep that concept clear. So I'm gonna justify now. So vertical is gonna be trans 0. You can also do the other way around. You just need to keep track. Horizontal is gonna be trans 1. Okay. So now we are going to make the axes. We need more axes. As you might remember from tutorial 2, we need 4 axes on the bow. So 2 that we are where we are touching the plate with the small mass, and we can move, or that axis can move left, right, and up and down, and 2 on the large mass where we are actually with controllers controlling how it's moving. So the small mass is following. And then of course 2 on the plate where the bow is touching, and at least 1 output. So let's get to that. Set Q. I'm gonna call the my bow touch. V is gonna be make axis on my bow at constant small mass is 1, and this is vertical, so trans 0. I'm going to copy that, and for my bow touch horizontal, it's gonna be trans 1. Now the next 2, we can also just copy that, these 2. It's my bow movement, for movement. So what we are moving, it's gonna be, instead of 1, 0. Move V, move H. Trans 0, trans 1. That's how we defined it. Okay, so that's the connections here. Then the axis is on the plate. Set Q, my plate. Bow vertical. So it needs also there 2 axes, although we're gonna type in the same thing basically. So make axis my plate constant. Now we have to decide on the plate where we want to bow. So I'm gonna take maybe 0.3, 0.4. That's good. And on the plate, the axis is of type normal. We're going to copy that. And we basically are going to use the same again, just change this name. We just need 2 axes to combine or to connect with these 2, right? Okay. And last but not least, set Q, my plate listener. Make axis my plate constant, let's say 0.7, 0.8, so on the other side a little bit of the plate, and also normal. There we go. These are the axes. So now it's time to make the connections. Okay, so we are going back to the connections bow. Okay, so make connection bow. Now we need the vertical axis of the object used as a bow, so my bow touch V. Then the horizontal one, so my bow touch H. Okay, and the initial vertical position, so we are going to put it slightly above, so 1 centimeter above. Okay, next where it touches the plate, so my plate bowed, first the vertical one, then plate bowed, then the horizontal one. There, I think it doesn't actually matter, but we described it like that, so that keeps things in quite a good overview. So this is at 0, and the 4-dimensional controller, I'm gonna just write constant 2. That's the standard, right? Okay, so let's evaluate, see there is no, the console is happy. Okay, so now let's move the bow. We're again going to use the position connection and the speed connection. Okay, first the position for vertical. So make connection position, and we are gonna move the my bow move vertical. And then we need the controller. So make controller envelope. So we have done this before. So at time 0, this is going to be at 0.01. That's where it is, above the plate. At, let's say, 0. We want to slowly go down, so after half a second it's at minus 0.001, so 1 millimeter, so very light bowing. Let's maybe increase it a little bit, so at 2 seconds it would be minus 0.004, and then it lifts slowly back, so at 4 seconds, maybe back to 0.001. So that's just the vertical position. So it presses down a little bit on the plate and then moves up again. Let's make the connection for speed. Make connection speed. My bow move H. Make controller envelope here as well, envelope 1. So at time 0, let's say the speed is 1. Then at time, maybe 2 together with this. It's at 4, and at time 4 seconds, it's back to 1. It's lifted, and that's it. Any console? No. All is good. Okay, let's now go to output and synthesize. So make point output, my plate listener. Then we are going to run it for 6 seconds and play it. Okay. Ah, nice. Okay, so the pressure is keeping down, so let's keep the pressure. Nice. Nice. Okay. So these are some very nice things. So at the bow connection, maybe let's try something slippery. So let's see what difference we have here. If we put in 10, 30, 17, 0.5. Okay, there is this kind of slight touch. So I'm just trying things out. Maybe 3, 12, 6, 3. It's nice. I like it. Okay. You can also press deeper, so really press down. Ah, now we are getting the Now we are getting really the nice deep frequency of the 60 Hertz with enough pressure. Very, very nice. You can also then go up with the modes to get more of the high frequencies that would be there. And what would Modalys be if we couldn't put in some properties of a nice material which is rare? Diamond. Let's take diamond. Okay, I want the plate that is made out of pure diamond. 3,500. The Poisson is 0.2. And here it's 1.22 E12. That's not so big of a difference. Maybe we can make it sound longer and have a little bit more modes, 400 maybe. And if we make it sound longer, we should also run it longer, because else that sound gets cut off. Okay, now it takes a little bit longer to load as well, because it runs back through all the seconds. Here we go. Aha! I'm starting to feel very zen about this. So yeah, let's move over to OpenMusic and build this here. So I'm gonna just save that as bow 07 bow plate.lisp. Never forget the Lisp. Okay, here let's make a new patch. 07 bow plate. Here we go. Okay. So let's do a diamond plate here, getting bowed. We are gonna load the library. There we go. And we're gonna need a B2Mast today. I'm rect plate there, and now we are gonna type in the density. No, it's size. Okay, 60. So this is now pretty much forward, I think. So let's put in also fear 4. Let's put also in 400. Length and size are done. Thickness as well. 3,500 is our diamond. Here it's 1.22 E12. And here it's 0.2. And what we took here is 0.8 for the frequency loss and 0.3 for the constant loss. Okay, now let's go over to the axes and not get confused. Axis. So we need 1, 2, 3, 4 bow axes and 1, 2, and 3 plate axes. Okay. There. These are the two that are getting moved. So let's keep it that way. So we are first gonna object combine all this. And this. Okay. Do put in the arguments. So this is the movement, so 0 at trans 0. So that's vertical movement, and here is the horizontal movement. That's also 0, but trans 1. Right? Trans 0, trans 1. Same here, but with 1. Yeah. Trans 0 and here 1, trans 1. Okay. Here what we have is 0.3, 0.4. Here as well, 0.3. Oops, 0.3, 0.4. And both are normal. And here is 0.7, 0.8, and normal. There we go. Now let's do the connections. So mlis position connection is one that we need all over there. We need the mlis speed connection over here. For the horizontal movement, then we need the bow connection. Bow. Oops. There. And we need an mlis point output. Hey, mlis point output. There. Okay. This is connected like that. Here. Okay. So the vertical is here. The horizontal is here. Never ever mess this up. You will be very disappointed, and the console debug messages are not always the clearest. That's 0, and here is the controller, so 3, 12, 6, 3. Okay. Then let's do here the position. We need mlis envelope. We're gonna need it 2 times. I'm already putting it in here as well. Envelope. Oops. And we need the BPF twice. Okay, so this goes here, this goes here, this goes into the controller, this comes here, and this goes into the controller as well. Now we just need to make the same, or as you wish. You can also do different envelopes, but I'm gonna stick to the same I have here. So for the position, the x-axis is 0, 0.5 to 4. And for the y, it's 0.01, minus 0.01, minus 0.01, and 0.001. There we go. We need here 4, 3 or 4, 3 actually, but okay, should be good. That's our bow pressure down and up again. And oops, here we are going to do the speed. So 0, 2, and 4. It's a shorter one. And 1, 4, 1. I'm going to put them 2, even though it's not really necessary, but just for good measure. And now we can output and synthesize. So mlis new, mlis run, mlis synthesize. Oops. And the sound at the end. What can I do here? Markers now. That's not what I want. Okay. Let's make the outputs that we need. So new always at the start. Then let's connect all the possible controllers, or rather say connections, not controllers. Let's keep that clear. The output is also clear here, there, and then run it. What did we say? So for 10 seconds. Okay, so let's evaluate. Looks good until now. And here we go. That's a good sound to start the morning. Okay, let's move over to Max, because there are some tips and tricks we can do there. Okay, we have to build it up again. And as always, Max is its own thing. Load bang. Okay, the button. We need a mlis position name pos. There. We also need an mlis speed at name speed. So you can see now slowly the pattern over the tutorials that we have the controllers at the very top. Now let's go further. So we need the bow, mlis, which is a B2 mass at name my bow, but this bow has 2 inputs and 2 outputs. So this goes in and this goes in. And next, this bow is connected through the mlis bow connection at name bow con with 2 inputs, 2 outputs. We need both dimensions, so vertical and horizontal, to the mlis rect plate, also with 2 inputs, 2 output, 1. Well, let's make it stereo in Max for once. Although in the tutorial you are gonna hear it. I don't know why exactly, but my screen record only records mono for some reason. And I haven't switched to OBS yet. Name my plate. There we go. And if we do output, so mlis point output, we are gonna do at name out 1 at channel 1 and mlis point output at name out 2 at channel 2. There we go. There we go. Everything gets connected, as always, to an mlis script. This gets connected to Modalys. So Modalys with 1 input through the script and 2 outputs, because we have 2 outputs here. We can already prepare control list as a message just to check if everything is there, with the print object attached. Have the life gain here. Oops, come on, there, and an easy DAC. There we go. Okay. Now let's put in all the parameters we need. in the inspector. So we have the position, which we are going to control from outside. But the position starts at 0.01. I have experienced that sometimes it doesn't work if I don't put it in here. So I usually do it. The speed, we shouldn't have to do anything. Okay, so now the axis type. So we have vertical, which is trans 0, and trans 1, which is horizontal. So that order is good. How we go in, what we control is 0, 0. So that's also good. Axis in, initial position. What goes out, so what is touching, is 1. So bow touch, vertical, horizontal is also in the right order. We are not touching the constant loss, nor the pitch, nor the mass, nor anything else. So everything seems good here. The endless bow, we are going to change this here. So we have 3, 12, 6, 3. The initial position in is at 0.01, and the initial position out 0. That's what I have anyway. Understand it right? Okay. So that goes to the rectangular plate, and here we can now, well, if I deduct logically from the name, the axis in initial positions x are the two x values, so 0.3, 0.3. Please tell me in the comments below if I'm wrong, but that's how I deduct it, because else in my head it would be called axis in initial position 1 with this 0.3, 0.4, and then 2, but it's called like that. So, and then this, if I understand right, would be 0.4, 0.4. The axis out is 0.7, 0.7, okay, and here 0.8, 0.8, I guess, right? Okay, the constant loss is 0.3. The density of our diamond is 3500. Frequency loss we put at 0.8. The length is used to tune it. We have 400 modes. We have a pitch originally at 60, but we can change that from the outside. The Poisson is at 0.2. Thickness is 0.01. The young, I still suspect, I'm not 100% sure, but I still suspect this is supposed to mean 1.22E12. Okay. We have this and this, so that should work. Let's look into the console. So trigger the script, control list, everything seems to be here. So now we can make our controllers. And then we are gonna make some new controllers, a little bit different, just to show you a different method. Although I'm not sure it really makes a huge difference. I don't know how the Modalys object itself is programmed inside. But let's first do align 0 point twice. So one will be the pause at position $1. So that's for our vertical control. And this will be speed at speed $1 for our speed control, which basically if I might say so, I think, gives us an endlessly long bow. The bow is endless. It can just go and go and go and never has to change direction. But if you, as in the, I think in the Modalys example itself, one of the example patches, they use position for both, and then you can kind of bow back and forth. So I'm gonna just make these envelopes we go from 0.01 to 0.5 to minus 0.01 in, oh, I forgot the comma, sorry, minus 0.01 in 500 milliseconds. Then we stay there at 0.01 for another 1500 milliseconds and go back up to 0.001 in another 2000 milliseconds. That's this. And our speed controller is going from 1 to 4. 1 to 4 in 2000 milliseconds and then back to 1 in 2000 milliseconds. I'm gonna trigger those at the same time. I'm gonna do a normalize 0.5. It can be pretty soft, non-normalized. Okay, I'm gonna save the patch, build the anticipation 07 bow plate. Okay, here we go. Okay, the attack was very different. Ah, no. So there is this little kind of, I don't know if I should call it bug, but I usually have it the first time it gets played, it has this kind of attack. And then, I'm gonna put it a little bit down there. And then it gets really nice. Then it's as expected, but just the first time I trigger it. And another technique you can use to do this, but I don't know, because I'm not linked to the earcom in any way, I don't know if it makes a difference. I don't know how these messages are handled. All I know is that usually in Macs, if you are sending in at signal rate, it's usually considered as better, unclicky. But I don't know if these messages, it sounds to me as they are converted to signal rate in some way inside of this object, but I'm not completely sure. And you can send these controllers in at signal rate. So let's just do that. So what you need is basically an mlis.point input. So at in1, at name in1 has to be together there, and make this to a signal. So mlis.signal. There, there, and there. So then this would be a signal, and we would copy it in, oops, in 2. And now here I would need 2 inputs. And I wouldn't send this as messages, but I would make a line tilde. So send it in as a signal. So I would trigger this, go in here, and this should work as well. Ha! Well, a pretty cryptic error. No, doesn't want to do it. The thing is that it started first and then blew out this error. So I'm not sure what happens here. Maybe I should just give it the name sig1 and sig name sig2 and try again. So I'm gonna do something. I'm gonna save it. I'm gonna close Max. I'm gonna restart Max. And I'm gonna reopen my patch. Turn on the sound. Let's see. Ha! Okay, so it does some kind of sound and then it freaks out. And but at the same time, I have had examples where exactly this kind of setup worked. So it's a little bit of a mystery to me, but with messages in any case, it works. And these boat plates have a really, really nice sound. So I hope you enjoyed and see you on the next one.